A train is traveling at 50 kilometers per hour on a curve, the radius of which is 500 meters. If the distance between the rails is 1.5 meters, find how much the outer rail must be raised above the inner so that there may be no lateral thrust on the rails. Now, let's say on rounding off this curve, this train, we raise it as a certain distance. So, we are raising one rail on top of the other. Now, that would be too much. So, diagrammatically, let's say this is how it is going to be. So that means the other rail is going to, the other portion of the rail is going to pass on top like that because we've raised it. Okay, so, and we have got our train here which is moving. So, like that. Now, because we've raised this, we've raised one wheel above the other, that means there is a certain angle here and a certain height h. Now I've been given the distance between the two rails. So if one wheel rests on this point, the other is going to rest on that point. The distance between those 2 points is what has been given as 1.5 meters. So that's the distance here, 1.5. Okay. Now from here, let's look at the forces which are acting on this mass which is here. The first force acting on the train is the weight force which goes down. And this is going, we also have another force which is the normal force making 90 degrees to the surface. There is the normal force. Now we are going to break this normal force. We want to have only forces going in the y or in the x. So we can see already the weight is in the y, and that is in the negative y direction. So let's break now the components of the normal force into the x and into the y. So this is going to become like that. Okay, and then another component is going to be in that direction, so broken in two components now. So one thing that we need to realize is if I get to extend the normal force in this direction, can I use just a different color? So if I get to extend this normal force in this direction like that, the angle of the incline is going to be equal to this angle. And from what we know, if we have got lines which are crossing like this, the angle here is going to be equal to the angle here. So therefore this angle which is here is going to be equal to this angle which is there. Okay, so that is going to be theta. And since we know that this angle here is equal to the angle of the incline, then even the other angle is theta. So that is one thing that we need to understand. So therefore this is going to be theta at this point. Now what will be the x component? Look at this. The y component that we've broken is adjacent to the angle theta. And so whenever something is adjacent, we are going to use the trig ratio of cosine. Therefore this is going to be n cos theta. If the y component is n cos theta, then the x component is going to be n sin theta. Okay, like that. So working with the forces in the y, the net force in the y direction should be equal to what is going up, we have got normal force cos theta. What is going down, we have got mg. So the net force, because this thing is not going up or down, the net force in the y is going to be 0. We have got normal force cos theta minus mg. So from here I can take mg the other side. That will give us normal force cos theta is equal to mg. So that is going to be the first equation. Now, if we look at this, whenever something is rounding a curve and we've been given the radius, there is always a force pulling it towards the center of that curve. And in this case, that force pulling it towards the center of the curve is actually equal to the normal force sin theta, or the x component of the normal force. Now, what do we call that force which pulls things towards the center? That's a centripetal force. So therefore normal force sin theta is going to be equal to a centripetal force, and centripetal force is given by mass multiplied by velocity squared divided by r. So we have got this first equation and we've got a second equation. If we divide sin over cos. We know we get tan. So I'm going to divide the second equation by the first equation. That will be n sin theta divided by n cos theta, and that will be equal to n sin theta. What was on top is that is mv squared divided by r over, for cos theta, that is mg. So the normal force cancels. Sin over cos, that will give us tan theta. And tan theta is going to be equal to this mass is going to cancel out with that mass. And so what we are going to have here is v squared divided by r divided by g, which we can just say rg. That is because if we've got v squared over r, we can also write this as divided by g. And to change the sign into multiplication, the g goes down, and so we can see where it comes from. So this is the equation that we are going to use to be able to calculate the angle of the incline here. Now firstly, I need to convert the velocity into the SI unit for velocity. So velocity is given as 50 kilometers per hour. So I need to convert to meters per second, so multiply. So we've got a kilometer on top, I'm going to take a kilometer down. And we want a meter. So in 1 kilometer, we know we have got 1,000 meters. So the kilometer and the kilometer will cancel. Now we have got the hour down, so I'm going to put the hour on top. We want a second down. In 1 hour, we know we've got 3,600 seconds. And the hour is going to cancel. So we just get to multiply 50 multiplied by 1,000 and then divided by 3,600. And that is going to be 13.88 meters per second. So you can now go on and substitute. Therefore, tan theta is going to be equal to the velocity, that is 13.88 squared divided by the radius. What is the radius here? We've been given that the radius is 500 meters. So that will be 500 and then multiplied by g, which is 9.8. So tan theta is going to be equal to 13.8 squared divided by 500 multiplied by 9.8. So that is giving us 0.039367. So to remain with theta, we're going to take tan inverse of 0.039367. And that theta is going to give us about 2.254 degrees. Now that we know theta, we want the height. Find how much the outer rail must be raised above the inner rail. That is the height. Now we know the angle and we know the distance, which is here between the two rails. We know that. We want the height. So what we have got a triangle like this. The height there, and this is 1.5, and then we've got the angle theta. So we are relating opposite and hypotenuse. What are we going to use? We are going to use sine. So therefore, sine theta is going to be equal to opposite, which is h, over hypotenuse, which is the distance. Therefore, height is simply distance sine theta, and the distance here is 1.5. Sine the angle theta is 2.254. So let's get to punch. We see what we're going to get. 1.5 sine 2.2. So that is about 0.05900 meters. So we can as well convert this number to centimeters just by multiplying by 1000. And that is going to now give us, the decimal point is going to move 1, 2. So that will be 5.9. And 5.9, we can just write it as 6.0 centimeters. And so that is going to be the answer for that one.